Hi, ladies. When you're watching this, it'll be Wednesday, April 22nd, and this will be day 4 that we're working on chapter 4. Looked at the survey results from Monday, and looks like things were going pretty well. Looking at some of the answers, it looks like also things were going pretty well with what we were working on. So today we've got prayer, some updates, prime time, and while you guys are kind of coloring this prime time page, I'm going to show a video that's just really for entertainment. I'm going to go over the homework classwork answers from last time, which was in your green packet. We're going to talk about isotopes. I guess not we. I'm going to talk about isotopes, then go over classwork and some things looking ahead. So let's start off with prayer. In the name of the Father, the Son, and the Holy Spirit. Amen. God, grant me the serenity to accept the things I cannot change, the courage to change the things I can, and the wisdom to know the difference. Living one day at a time, enjoying one moment at a time, accepting hardship as a pathway to peace, taking as Jesus did the sinful world as it is, not as I would have it. Trusting that you will make all things right if I surrender to your will, so that I may be reasonably happy in this life and supremely happy with you forever in the next. Amen. In the name of the Father, the Son, and the Holy Spirit. Amen. We've done that prayer. Actually, part of that prayer is on the little prayer cube that we have in class, but it's really only the first part of it that's listed on the cube. But when I looked it up to try to copy and paste it into this PowerPoint, I found the entire thing as well as the name of the gentleman, I think, who wrote it. I have no idea how to pronounce it, so I'm not even going to try. I do want to remind you that there are some special intentions here that some students have been adding to. I've noticed there's a few more that have shown up since the last time. So ladies, please keep all these people in your prayers and in your thoughts. We've still got a road ahead of us, and I know that all of our prayers are really important, especially to all the people who've been requesting them. So, class update. So since I recorded my last video on Sunday, the governor had his announcement on Monday afternoon indicating that schools in the state of Ohio are not going to be returning to the school building during the current academic school year. So we now have the answers to our questions. So we are not going back. And I received a couple of questions from you guys regarding some of the things. I don't have a ton of information, but the information that I do have, I can share. As far as getting into the building was cleaned since we were there before. And from what Mrs. Hoke was telling us during our staff meeting, they want to keep it clean and sealed as long as possible. So currently, we are not allowed to get into the building. They are planning on opening the building up. At what date? I'm not sure. My understanding is that's probably going to be the beginning of June, and that there will be some type of staggered entry into the building based on grades and last names, so that we don't have too many people in the building all at the same time, so that you have the opportunity to get in, clear out your lockers, get whatever things you have in there that you need. But they're going to try to do it in a controlled manner. And the same will be true with the teachers. We will only be allowed in there a handful at a time. There was an email prior to spring break regarding finals, and there are no finals going to be happening. So school will be done before we actually get to finals week. So the week before Memorial Day will be the end of classes for us. And there are not supposed to be finals. There is not 20% of your semester grade that will be contributed to by a final. So that means that whatever you have in your classes for the part of the semester where your classwork, homework, tests are all contributing, that will be your semester grade. So that will be 100% of your semester grade as opposed to 80%, and that will be true for all classes. I was asked for this class, will there be some sort of final project? And the answer to that is no. I am not planning any sort of final project. I think that there is content that I would prefer to cover with you guys, give you guys an opportunity as best as I can to at least have the opportunity to work with some of this content that's here at the end that I think is important that you get an opportunity to see. And so I do not want to do anything regarding a final project. I was also asked about review questions. We are not continuing them at the current time. Teachers were asked prior to spring break to cut back on the classwork and the timing and everything, and review questions was something that I felt we could just get rid of and save those 5 or 10 minutes because they weren't that important. Math videos. I've already posted a temperature conversion video. It is accessible through Edpuzzle. It's optional. I'm going to keep working on more based on survey results. I'm still kind of figuring out how I'm doing unit conversions, even though that was the one that had the most responses. I haven't figured out what all I'm going to do. If there's something really specific that you really want me to cover, please send me an email, because then I'll know that and I'll have the opportunity to include that in the video. The Chapter 2, Part 2 test, I'm currently in the process of scanning them. The last couple students who hadn't taken them before we left the school building have now taken them. It is a really slow process because I've got to scan every page and then save them by student name. As soon as they're scanned and emailed, I can actually discuss and post some answers to those. And in regards to how you can adjust those grades, I'm still thinking about that. Again, if you have some ideas, I am happy to hear them. I did not include here in this update, I know you have a curation project coming up to be due. I am going to say let's wait until we're done with this Chapter 4 material before you finalize your next part of the curation project, because we still got some content that we need to cover, and I don't think that based on what we've covered since you did the last curation project, you might not find enough to cover the links. So curation project deadline has been extended. I'm still aiming for a goal of having 10 resources in your link by the end of the semester. And we've got half of them done. We've got another 5 to do. And my dog is probably going to be kind of loud during the rest of this. All right, so personal update. I wanted to show you guys a little bit about Singapore. So first of all, I need to show you where Singapore is, because when my husband told me we were moving there when I was pregnant with my daughter, I had no idea where it was. So as you can see here, Singapore is marked by this arrow. We've got India here, we've got Thailand and Malaysia, Cambodia, Vietnam. China is up here. You can see Hong Kong and Taiwan. So Singapore's here, and it's a little dot. And if you zoom in to the very tip of Malaysia, which is down here, Singapore is this island here, and you can see the star here. Zooming in a little bit more, this is the island of Singapore, and these are the freeways that are here, these things in yellow. It is right across the waterway from Malaysia, and it is the Johor Strait. It is the ocean, but it's kind of like a wide river because it is not huge. You can see Malaysia when you are on this end of the island. So this is the island of Singapore. It is a city. It is a city-state. So when we moved there, I had actually never visited because I was pregnant when we knew, and I was working. And I had just had to trust my husband when he said it was nice and I'd like it. But Singapore is a relatively new country. It was part of Great Britain until shortly after World War II. So they speak English, and the national language is English. Street signs are in English. The cars are British. So, but when Great Britain surrendered to the Japanese during World War II, Winston Churchill referred to it as the worst disaster in British military history. It was tragic for Great Britain to surrender Singapore, and it was tragic for the Singaporeans to have the Japanese occupy their country. When we moved there and I learned more about the history of that, I was totally surprised at the Japanese and Asian perspective on World War II, because being in America, we really learn European history more. Even though the Japanese bombed Pearl Harbor and we fought as Americans against both Japan and Germany, we don't hear as much about the Pacific part of that war. I really had no comprehension. This past summer when we visited, I got my husband and my daughter to do a couple of the tours of the World War II museums and things, and they were both totally stunned. It was a part of the world's history that they didn't know, and it was very surprising because the Japanese were horrendous to the people of Singapore. It was awful. And we think of Germany being awful to the Jewish people, as well as other people that they persecuted and murdered. The Japanese were every bit as bad, if not worse. And that was very surprising to me. So Singapore kind of like started over after World War II because they had been bombed and the buildings were destroyed and the Japanese had come in and taken over. But due to its location, it has always had people from a number of countries that bring all of their food, religion, and traditions with them, including Chinese, Indian, Malaysian, Indonesian, and currently there's expats from all over the world. Singapore has made itself a very important seaport, and this Jurong Island area and some of this area that's down here is huge for shipping things to Asia. Things come from different Asian countries and go there, and then they go off to the rest of the world, as well as vice versa. But because there are so many different cultures, you get a lot of really good things. You get food, you get religion, you get their traditions, you get the experience of all these different cultures. But with all these different cultures blending, and the Asians are kind of known for being headstrong, they have a lot of challenges for blending all of those different country cultures together. And as a result, the government has been somewhat dictatorial. They're kind of referred to as a benevolent dictatorship, and they've had to instate laws about no urinating in public, no using the elevators as your bathroom, and no spitting on the sidewalk. And that actually was present during SARS, during a previous outbreak of the avian flu outbreak, and people would be spitting and their spit would have the virus in it and it would spread like crazy. So they outlawed spitting, and if you got caught spitting, you got fined heavily. And chewing gum became an issue because there were some kids who took a big, huge wad of chewed gum and stuck it in the doors of the Metro rail system, which goes all around the entire country, and it froze those doors shut and prevented them from opening, and it shut down the whole country. So the government didn't think it was really funny because it kind of paralyzed everybody for hours because they couldn't get people off, but then the trains couldn't move, people couldn't get home. It was a mess, and they out chewing gum in public. So they don't, and they also, you may have heard, actually maybe not, you were really young. There was an American who had vandalized somebody's car, spray painting it, drawing on it, and they were caned. It's not tolerated to not respect other people's property. So as a result, there's a lot of restrictions with that, but also it's really safe. I, by myself, could take my daughter when she was 1 year old and go downtown at 8 o'clock at night in the stroller and not have any fear that I was going to be mugged or I was going to have my pocket picked or that there was any issue. So there's good, there's bad, there's a balance. I loved living in Singapore. I'm glad I've had the opportunity to go back and visit a couple times. And I'll share a little bit more with you about Singapore. So back to our topics at hand. So chapter 4, we're kind of working our way through. We've covered some of the history. We're still working on electrons, protons, neutrons. We're going to start talking about isotopes today. I'm just going to do one coloring sheet on periodic table groups. We're still going to be working on this for a few days before we get into ions and ionic compounds. So for your prime time today, I would like you to take out your green packet and color page 25. I want you to note that this page looks a lot like page 24. So 24 is another periodic table, has a coloring sheet, has a different key up here. This one only has 3 items in it: metals, metalloids, and nonmetals. 24 is slightly different. So please just color 25 today. I'm going to do 24 next time, I think. And note, even though they use blue, green, and yellow, you are welcome to use whatever colors you have on hand. And if you have highlighters and you don't want to color them all individually and you just want to box the whole thing, that's fine. And I'm going to discuss the table in a lot more detail next week. But I want to point out a couple of things. So the yellow hydrogen here, really based on the way this color scheme is, belongs over on the side with all the other yellows because it is not a metal, it is a non-metal. However, there are other reasons to put it here in this very first column, and we'll talk more about that later. But just note that this yellow hydrogen is kind of by itself all the way over on the left-hand side of the page. In addition, there are some green ones here. These are called metalloids. It's referred to as the stair step. It's a like coming down a bunch of stairs on this side. These are kind of the border between metals and nonmetals, and they have properties of both. But these are kind of the key ones as far as the border between metals and nonmetals. And these black or gray ones down here, they only exist in the laboratory, so we really don't refer to them as metal or non-metal because they exist for fractions of microseconds, and they really don't have properties such that we can classify them one way or another. So while you color, to make a note, if you need to pause it to kind of make certain you know which areas you're coloring which, pause it for a minute, but I'm going to show you a short video, and this is really just for entertainment only, not for anything that you need to know about. It's kind of one of my family's favorite videos. They really like this video. It's a kid who puts a glow stick in the microwave and his dad's reaction. Some of you may have seen this at some point. So while he's starting this, don't do this at home. There's a whole litany of reasons to not do this. Looks kind of cool though. But again, don't do this. So that's the reason why you don't want to do this, because he just barely shook it. It explodes everywhere.
No clue what to do with this. I gotta see what to do, Ding-a-ling. God, I told you not to mess with it. Choking hazard, I don't know what to do if it's in your eye. God! Don't grumble.
Dad's reaction is classic. So he's trying to call somebody to figure out what to do.
Don't like women, Jack. You have another one of these tubes. Not to mention it's all over your awesome shirt. No. And it's not, I doubt it. Don't rub your eyes. Yeah, no shit. I said don't fight women. Don't screw around. What you do, put a beautiful shirt on and get it in your eyes. Am I ever right about anything, Jack? Am I ever right? Can you ever listen? Get this on. Help me! Dad! I'm trying, Jack. I don't know what to do. Okay, Dad. He's fine. Take some water. Contact with active skin may cause this temporary discomfort. Case of higher skin tuck, flush with water for 15 minutes. So just sit there and keep flushing away with water. Big hot bomb spider down too. Yeah, we're good at respect. I'm sorry, Dad. I'm sorry. Oh, I'm sure you're sorry now, Jack. You can always be sorry after. I'm gonna go blind. I'm sorry, I started to dial that. I hate thinking I doubt it. No, I got son that got stuff in his eyes, and then I finally found the directions of what to do for it, so I'm okay. No. My name's Josh. Just keep flushing it. Thank you.
So my family found that really entertaining. It was on a TV show, I think Outrageous Acts of Science. This is what happens when you put a glow stick in the microwave. They find it very entertaining with the dialogue between both the male and his father. And his father is like, sure, you're sorry now. Because obviously people do stupid things, but the reaction is kind of priceless. I'm not sure how they got that video. The article says that his brother was filming it. But don't put a glow stick in the microwave, because that was what would happen. Okay, so hopefully you found that a little bit entertaining. And I understand the kid was fine, and that video is really, really old. But so let's move on and go over some of our homework questions from last time. So green, page 12, bottom section, you had filled in everything at the top. There were 3 questions down here with you try that I asked you to do. The first one is, what element's neutral atom has 17 electrons? And by going to the periodic table and recognizing that the number of electrons equals the number of protons because it's neutral, it'll be 17. So the element that has the atomic number of 17 is chlorine. The next one was, how many neutrons are in a lithium ion? So going to lithium, it looks like the atomic number is 3. So that has the number of protons. And we know that neutrons is equal to the atomic mass minus the number of protons. So that is going to be 7 minus 3, which will give you 4. And the symbol of the cube in the upper right corner tells you that the element is naturally a solid. So many different versions of the periodic table will show some different information. And the photo that this is talking about references indicates if there's a solid, liquid, or gas at room temperature. And that is not something that's on our periodic table, but there are very common periodic tables that has that information, because sometimes that's really useful. So the next page that I had you guys complete for homework was green packet page 13. And I received a few questions about how to fill out this bottom part, but basically any number or element symbol that you filled in up here in the table, when you found that down here, you're going to want to color it in, and you should end up with this these two words, science rules. And just in case you have any of these numbers incorrect, I went over them here. So really quickly on the third line, which we did not do together, atomic mass is, it says that it's nitrogen, so you can find that the atomic mass is 14, the atomic number is 7, the number of protons equals atomic number, which equals 7, which is also the number of electrons because there's no charge. Neutrons equals atomic mass minus atomic number, which is 14 minus 7, which equals 7. The fourth line, the number of protons was given as 4, and that's the same as the atomic number. And you look at the periodic table and can find that the element is beryllium. And the atomic mass given is 9. So with the atomic mass of 9, you can write the standard atomic notation. Protons is 4, number of electrons is 4 if there's no charge. Neutrons is equal to the atomic mass minus the atomic number, which is equal 9 minus 4, which equals 5. The sixth line, we know that the element is krypton and the atomic mass is 84. The atomic number is 36 because it's given here. Kr is the symbol for krypton. Number of protons equals 36, which is also the same as electrons because there's no charge. Neutrons is the atomic mass minus the atomic number, 84 minus 36, which equals 48. And then the seventh line, we know the atomic mass is 27. So we have to go to the periodic table, find that the element is aluminum. Its atomic number is 13, which allows us to fill in the standard atomic notation. Atomic number is 13, number of protons is 13, and the atomic mass minus the atomic number is 27 minus 12. No, which is minus 13, which gives us 14. I have a typo there. Sorry about that. So, okay, so moving on to new work for today. Green page 14. Go ahead and copy the top part. We have 3 isotopes there, H1, H2, and H3, which are 3 hydrogen isotopes, which I talked about last time. The definition of isotope is atoms of the same element that have a different atomic mass. We also can say about this is that the number of protons determines the element, but the atomic mass includes protons and neutrons. There are heavier and lighter atoms, and they exist due to more or less neutrons. So right below here, it says number of protons equals the atomic number, number of neutrons equals atomic mass minus atomic number, and number of electrons equals number of protons, and that's true as long as you don't have a charge. There's a very important statement here, which I made a note of and kind of circled it in red here. So use the given atomic mass, not the mass on the periodic table of elements. The mass on the periodic table of elements is an average of all of the isotopes because we're trying to represent all of these isotopes of hydrogen with one atomic mass. So by taking an average of them, we are actually going to end up close to the number of the mass for the isotope that is in the majority of the hydrogen in the world. And we'll talk about where those numbers come from on Friday. So right below this, there is a practice down here, which I kind of cut off because I wanted you to make an attempt to see what you could do. But this uses another common notation to represent what we're talking about, and it's called isotope notation. So the number after the symbol and the dash is the atomic mass. So AR 38 is argon, and it has an atomic mass of 38. And by looking at the periodic table, you should be able to figure out the number of protons. And by doing that, you can figure out the electrons, and then you can calculate the number of neutrons. So pause the video for a moment, see if you can do those three. So how did you do? So we've got argon 38 has 18 protons and electrons and 20 neutrons. Titanium 44 has 22 protons, electrons, and also 22 neutrons. And then cobalt 56 has 27 protons and electrons, while it has 29 neutrons. So hopefully you did okay. So a summary right now of information that we've already been covering is elements are defined by the number of protons, always. That's how we know what element it is. Isotopes are defined by the number of neutrons. Sometimes they have more, sometimes they have less, which makes them heavier or lighter. Ions are defined by the number of electrons, which we are going to be talking about next week. But if your protons and your electrons are not equally balanced, you do not have a neutral charge and you will have a charge. So this last box here is a challenge, and this is not necessarily something I'd expect you to know, but carbon-14 has 8 neutrons, and it asks you to identify 3 isotopes of elements that have the same number of neutrons as carbon-14. But it has 6 of them listed here. Do a quick mental check and see, do these all have 8 neutrons? I believe they do, but I kind of have a note here that I think maybe one of them doesn't, but take a look. If one of them doesn't, let me know. Okay, then we're going to work on green page 15. I'm going to do a few of them, but there's only 6 here, and this page is really not that hard. So up at the top, we have directions that say, for each of the pictures below, decide if the pair of atoms are different elements or different isotopes. And we're going to write the chemical symbol below each picture. And what we're going to be doing is using the standard atomic notation. So for the first one, for number 1, with this one on the left, it says there are 8 protons and 8 neutrons. So we know that that sums to 16, which is the atomic mass. Looking at our periodic table, which I assume you have out, 8 protons being the atomic number, this ends up being oxygen. So we can write the standard atomic symbol as 1680. Let's also count the electrons and make certain that it is a neutral item. So just by counting these little circles here that are in the orbitals, we got 1, 2, 3, 4, 5, 6, 7, 8. So it's 8, it's neutral, there is no charge. For number 1 on the right, it's 9 protons and 10 neutrons, and that sums to 19, which is the atomic mass. 9 protons is the atomic number. This atom's going to be fluorine. And counting the electrons, there's 9 in the photo. Okay, so let's count the number of electrons. There are 9 in the photo. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And that means that the number of protons and the number of electrons are equal, so there's no charge. So now looking at the original question, these are not isotopes of the same element. These are obviously different elements. Oxygen and fluorine are not the same element. So we're going to end up circling atoms of different elements. And you can either circle or highlight that. So here's the answer to number 1. Number 2, the left one, 9 protons, 10 neutrons. Add those together, we get 19. So the element that has 9 protons is fluorine. So we've got 19,9F, and then we count the electrons. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 electrons, 9 protons, there's no charge. On the right-hand side, we've got 9 protons, 9 neutrons, which sum to 18. So it's 18(9), it's still fluorine. These two are definitely the same element. So we're going to circle different isotopes of the same element. I'm going to have you finish this page for homework. All of the rest of these are the same except for the last one, number 6. Number 6, when you go to count the number of electrons, they do not equal the number of protons. So for number 6, make a note underneath them how many electrons there are on both the left and the right, because we'll come back to these later on when we're doing ion notation and write the charge. If you want to try it and look at comparing the number of electrons and number of protons and figuring out what the charge might be, if you get that, you're going to put it in as a superscript on the right-hand side. Superscript is up. That's why it's super. It has UP in it. It means up. So you're welcome to do that. So pause the video and do those 4 now before you move on. So green page 16, I'm going to work through a number of these and then leave the rest for you to do for practice and for homework. I want to indicate to you that the top of this says that there's isotopes, which means that the atomic mass from the periodic table might not be what we're going to actually use, because it could be any of the isotopes that are present on Earth. So we don't want to assume that we can use that atomic mass on the periodic table. So if we have no other information that leads us to the atomic mass, which would be number of protons and neutrons, we can use the number of the periodic table, but first you want to exhaust every other possibility before you go to the periodic table for the atomic mass, because there are a whole bunch of isotopes for a lot of these particular elements. So let's get started. So the first line has isotope notation H2 and nothing else. So what do we know? We're given H2, so we know it's hydrogen. We can look at the periodic table and determine the atomic number, which is 1. And we know that the 2 in the isotope notation is for the atomic mass. So the standard notation would be 2, 1, H. Atomic mass is 2, the atomic number is 1. Number of protons is pretty easy because we know it's the same as the atomic number, which is also 1. The number of neutrons is the atomic mass minus the atomic number, or the atomic mass minus the number of protons, which is 2 minus 1, which equals 1. And the number of electrons, we have to ask ourselves, is this neutrally charged? The answer is yes. So the number of electrons equals the number of protons, which is also 1. So down in the bottom, I have the answers here. Ladies, if you're not working through these as I go, you're not going to be able to do the ones in the table by yourself. So work through these, pause the video, try not to look ahead, try not to just copy down the answers, because it's really not going to help you in the long run. So in the second line, we've got standard notation 14(6). C, so it's carbon. So we already know the element symbol, we know the atomic mass, we know the atomic number. So the isotope notation will be C14, the atomic mass is 14, the atomic number is 6. We know the number of protons is also 6 because it's the same as the atomic number. The number of neutrons equals the atomic mass minus the atomic number, or atomic mass minus the number of protons, which is 14 minus 6, which equals 8. And then lastly, the number of electrons. We ask ourselves, is it neutrally charged? Yes. So electrons equals number of protons, which equals 6. So moving on to the next line. This time we're given the atomic mass of 37 and the atomic number of 17. And we need to go to the periodic table to try to figure out which element it is. So atomic number 17 is chlorine, which has an abbreviation of Cl, or a symbol of Cl. So isotope notation would be Cl37. The number of protons equals 17, which is the atomic number. The number of neutrons is 37 minus 17, which is 20. And the number of electrons, if it's neutrally charged, it is the same as the number of protons, which equals 17. And one of my dogs, Coco, is kind of going crazy. You probably can hear her in the background. She's whimpering because there's been a lot of wind. Fourth line. Number of protons equals the number of, and number of neutrons are given. So number of protons is 28, which is the same as the atomic number. Neutrons is 30. We can also figure out the electrons because if it's neutrally charged, there it's the same as the number of protons, so that's 28. Atomic mass equals the number of protons plus the number of neutrons, so 28 plus 30 is 58. The atomic number is 28, the same as protons. And we've got to figure out the element on the periodic table. So what do we use? Do you remember? Is it atomic number or atomic mass? It is the atomic number. So number 28 is nickel with a symbol of Ni. The isotope notation is Ni-58. And the standard notation is 5828 Ni. So the fifth line, we're given neutrons and electrons. Neutrons is 32, electrons is 28. Number of protons is the same as the number of electrons if it's neutrally charged, so that's 28. That's also the atomic number. The atomic mass is protons plus neutrons, so 28 plus 32, which equals 60. Atomic number is 28. We need to find the element on the periodic table. And number 28 is nickel, still nickel. So it's Ni. So this is Ni-60. So the standard notation is 6028 Ni. So skipping a bunch of lines because these are all of the ones in between are pretty similar. I want to go down to the 9th line that looks like this. It has 79 for the atomic mass and 44 for the number of neutrons. So from this, we can figure out the number of protons because the atomic mass minus the number of neutrons is going to be the number of protons. So 79 minus 44 is 35, which is the atomic number. It is also the number of electrons because it's neutrally charged. We have no information telling us that it isn't. The atomic number is also 35. So then we need to figure out which element this is using the periodic table. So the atomic number of 35 is bromine, or symbol Br. Isotope notation, Br-79. Standard notation, 7935 Br. So I'm going to have you finish the rest of this page for homework. The bottom part is just like the last page you did in the green packet that was due today. You're going to color in all of the numbers that you fill in and the symbols, and you're going to shade those in, and you should get a message down in the bottom. So recommendations, very similar to last time. Keep your periodic table nearby. Work slowly and carefully, line by line. Keep something nearby with the key information that allows you to identify the different things. And I've summarized them again today. Atomic number equals number of protons always, and it identifies the element. Atomic mass equals numbers of protons plus number of neutrons always. Atomic mass that's given on the periodic table is an average, and so it may not always be identical to the one in these little tables that we're looking at right now. Number of electrons equals number of protons sometimes. It's only if the atom or molecule has no charge. And I want to remind you, don't ignore this step because the very next set that we do of these are going to have ions in them, and there's going to be some charges, and you want to be able to be practiced in paying attention to electrons and protons. So we have 2 more pages of these kinds of table things in this green packet. Some will be where the number of electrons do not equal the number of protons. And hopefully by the time you finish this page 16, you're feeling more comfortable with these now. So kind of heading towards my wrapping up polyatomic ions. Reminder, try to work on a few of these. These really will make your life easier next year. I promise you, they will actually make your life easier in chapter 5. So hopefully you worked on the 3 that I mentioned in last class, nitrate, bromate, and ammonium, and memorizing the formula and the charge. So the 3 I recommend for today are carbonate, which is CO3 with a -2 charge, iodate, which is IO3 with a -1 charge, and hydroxide, which is OH with a -1 charge. These are all really important polyatomic ions, and we'll see them a lot in the next chapter, as well as when you start writing reactions. So turn-in work due Friday. We've got green pages 14, 15, 16, and 25, a lot of which you did today while you were working through this. So I don't think you have a ton that you have to do independently, but you do have a few. The survey is there. It'll be open until Thursday late afternoon when I'm actually recording the video for Friday. So please, please put your answers in there. Those are so helpful to me, ladies. Really give me an idea of what you guys are thinking. And I'm also appreciating a lot of your comments, your feedback, and some information that allows me to get to know each of you guys a little bit better, even though we're not face-to-face. So it's really, really helpful. And I am giving bonus points every time you guys complete the survey. So chapter 4 bookwork, I am just kind of keeping this running. All of these were listed previously. The only one that's new that I've added is 4.8, which is the intro to the periodic table, which starts talking about metals and nonmetals and metalloids. It covers a little bit more than that, but that's kind of where we are as far as if you were still reading the book. And ladies, it is helpful, especially if there's any of these topics that you are struggling on or you just need something else to look at. Feel free to take a look at your book. Your book is still pretty good. At least I think so. I've posted all these answers up on P-Learning. They're there anytime you want to take a look. Looking ahead, I am working on the next one. I did finish the one. The other one, I've got the PowerPoint going, and I will keep doing that. I am scanning Chapter 2, Part 2 tests. I can't guarantee I'm going to get those all done by the end of this week, but I should have them done by the end of the weekend. And candies, I am going to have you do some models of elements over the weekend. So if you did not retain some couple of small candies, 25 to 30 of each, you're going to want to kind of grab some of those or think about those for the weekend. We're going to use these to represent some protons, electrons, and neutrons. So you're going to want to have those if you don't already have them. So ladies, I just looked at the survey questions and a couple of the questions that were in there, and I believe I've covered everything except for one comment about the fact that if we don't go back to school, I don't get to see you guys again. I've heard a few ideas being tossed around. I don't know how likely they are, but one idea that I heard that I kind of thought was a reasonable thing was when we do have an opportunity to be back in the building all together, that you guys have an opportunity to run through your sophomore A and B day, not as a class, but just as a full day, all of your classes kind of back to back with a lunch break in the middle, just to kind of see your teachers and say hello and see your classmates and kind of have closure on your sophomore year before you guys actually start in your junior year of classes. So if this is something that is important to you, please get your thoughts known. I've heard a lot of people discuss about closure for the year and wrapping up and how we didn't actually get to like say bye. We didn't get to say like have a great summer. And that's kind of hard. It's really hard for seniors, but I don't think that means that it's not hard for you guys too. So if this is something that is of concern to you, important to you, make your thoughts known. And if that means emailing me, putting it in a survey, having your parents contact administration, making certain that that's on their radar, or you like the idea that I just mentioned, please definitely give that feedback to some of us. While I don't get to make the decision, I can at least pass the information along. So ladies, gosh, I can't believe that we've been doing this for so many days, and now we know that I'm not going to see you, like, I don't know when. It's really sad. So ladies, I really, really miss seeing you guys. I hope that you're able to piece through doing some of this stuff with this class. I'm really trying hard to help you guys out as much as possible. And if you have questions, concerns, anything, please feel free to send me an email. So ladies, until next time, take care.